Okay, let's talk about energy flow and chemical cycling. You've got energy flow. That's when the producers absorb the solar energy and they, by photosynthesis, make organic nutrients, and they can use these nutrients by themselves, or others can use them, and then the energy then is going to dissipate into the environment as heat. Only a small amount of the original energy is transferred. Then you've got chemical cycling. That's when the producers take in the inorganic nutrients from the physical environment. And it's important to note that energy flows, but chemicals cycle. Still having the problem with it advancing. Okay, so if we look at this diagram, we see solar energy taken in by the plants, and we produce some heat, and some of the energy is transferred to the consumers, the rabbit and the fox, and some is given off as heat, and some is transferred to the decomposers. Some of the energy and the nutrients goes to the decomposers, which break down those consumers, and some's given off as heat. Some of the nutrients are transported or transferred to an inorganic nutrient pool, and then some of that goes back to the producers. So you can see how it cycles. Energy flows. You see it goes from producers to consumers to decomposers, and then it flows out. But your nutrients cycle. They go around. That's the gray arrow. From the producers to the consumers to the decomposers to the inorganic nutrient pool back to the producers. And here you can see that animal, by cellular respiration, is releasing heat to the environment. And it's going to use its food for growing and reproducing, and that's going to give energy to carnivores that eat that animal. And then when it dies or excretes or defecates, it gives energy to the detritus feeders. So let's talk about a food web. These are the interconnecting paths of energy flow, and it describes trophic or feeding relationships. We've got a grazing food web that's going to begin with a producer, and it moves through successive trophic levels. And then you've got a detrital food web that begins with the detritus. And the members of the detrital food web can become food for the above ground carnivores. So you see a connection between detrital food webs and grazing food webs. And this is showing an example. And you can see that we've got the producers here, the leaves, the grass, the nuts that are produced on those trees, the acorns, and the insects and the rabbits and the deer are going to feed on the leaves, and the birds and the chipmunks and the mice are going to feed on the fruits and the nuts. And that makes them omnivores because they also will eat caterpillars. So you can see how it flows. A grazing food web flows from producer, in this case the oak tree, and the insects and rabbits and deer eat the leaves, and the birds and the chipmunks and the mice eat the fruits and the nuts, and they're omnivores because they also eat the caterpillars. And then the caterpillars are also eaten by birds, and the birds are eaten by the hawks. Now, a detrital food web begins with detritus, and that is the food for soil organisms like earthworms. And the earthworms then get eaten by carnivorous invertebrates. And then those invertebrates can be eaten by shrews or salamanders. And then, as we said a while ago, it can become food for above-ground carnivores. And that's why the detrital food web and the grazing food web are joined, from detritus to earthworms to salamanders. That's an example of a detrital food web. And we actually have more energy going through the detrital food web than through the grazing food web, even though it's not as complex, has fewer organisms. Now, as we said, trophic levels are feeding levels. So all the organisms that feed at the same level in a food chain. That's a trophic level. Only about 10% of the energy of one trophic level is available to the next trophic level. That's why there are fewer top carnivores. You're going to have more producers and more first level, the herbivores, first level consumers, than you are second level consumers and third level consumers. Ecological pyramids depict the flow of energy. And as we said, we're going to lose some as we move up the successive trophic levels. And sometimes you base it on the number of organisms, which is the biomass at each trophic level. This next picture shows you an ecological pyramid. So you've got the autotrophs at the bottom. That you've got more autotrophs than you do herbivores, which is the second level, and more herbivores than you do carnivores, which is the third level. And then the top level, you've only got one or two organisms up there. It's a much smaller level. And if we look at the biomass, we're looking at the 809 grams per meter squared, or 37, or 11, or 1.5. You see how the biomass decreases as you move up the ecological pyramids.